Peter, are you outside with no shirt on, soaking up sun?
Yep. First nice day out.
Oh, where you're in where are you?
New Jersey.
Oh, first nice day.
Yep.
Right. And do they have the Jersey Shore open?
They closed all the beaches down, but yeah. Just
Yeah,
hanging out.
that's one of the things that's, I guess, been easier for us in Florida, whereas y'all are starting to get nice weather and want to get out, and they don't want you getting out. And
Yeah.
you know, here if we miss a day of nice weather, oh well, it'll be there tomorrow.
Yep. It's always nice.
It really is. I've been here 20 years, and yep, it's good for me. So, how are you doing?
Pretty good. Yeah, can't complain.
Yeah, I just an hour ago, so I'm found out our oldest child that lives in Los Angeles, his wife is pregnant with our second grandchild,
Oh,
and
awesome.
is due in May, and they're both tested positive for coronavirus. And she's in the hospital with pneumonia, and they may have to, do a C-section and take the baby, but then neither one of the parents can be around the baby. So I just found that out about an hour ago. So I'm kind of,
Oh, that's horrible.
I
Sorry.
know. Thank you.
Keep them in my prayers.
Thank you. I appreciate that, because we're prayerful people. And yeah, we just got through talking to him, and of course um, they won't let him near her.
Yeah.
And so, it's kind of hard. Your wife is, she's got pneumonia, and on antibiotic drip. And at first he was just staying, he didn't want to leave the hospital. So he was staying in his car in the hospital parking lot. But he realized how futile that was,
Yeah.
he needs his rest. So anyway, he went home and is just waiting for the doctors to come in to decide what they're going to do, But anyway, if you want to go ahead and in course content information, we're going to do time value of money today. And in course content information, you should see a file, TVM problems.
Opening it up now.
It should be there. I did it before. I did it yesterday.
TVM practice, in-class practice problems?
Yeah.
Okay. Is it the first one or the second doc? Or are they both the same?
No, what is one's TVM problems is one bonds and installment, I mean.
I'm opening them both up now. One's an Excel sheet, one's a Word document.
Excel sheet.
Okay.
Thank you. And it's all pretty?
I'm trying to open it up now. Oh, yeah.
It's all pretty, huh?
Yep, everything's set up.
Yeah, so you're going to do it in the calculator and Excel.
Gotcha.
Yeah.
So we have to use the formulas, or we can...
I'm going to teach you in both. So you need your calculators, and I am going to teach you the time value of money formulas in Excel.
Okay.
So you're going to do both, because as business majors, we need both. So get your calculator, make sure you have your BA2 plus.
Gotcha. I'll have to
I'm glad you have nice weather.
Yeah, no, it's so nice. It's good to get out in the sun. Been locked inside all day.
All day? You mean all 3 weeks?
Yeah.
Just one day, that's all? Come on.
Wish.
You've been doing this for 3 weeks now. God.
New normal.
Well, God, I went to the drugstore yesterday to pick up some prescriptions for my husband, because, he's older than I am. And I went in and I mean, I had gloves on because I'm not opening the door of a pharmacy
Oh
with
yeah.
my bare hands. So I had gloves on and I had a mask on. Not that I'm sick, but you know, people are asymptomatic and have it. So, but when I walked into the pharmacy, into Walgreens, I wasn't the only one with gloves and masks, so it was okay. You know, and then I'm carefully taking the gloves off, you know, how you're supposed to, where and throwing them away and before I touch my car door. Oh, and then I still feel nervous about it, you know,
Oh yeah.
the stuff you bring home and is it on the surface and
All the
so,
anxiety.
yeah, trying to during this supposed to be peak time, bad time, trying to just not go, like hopefully that was my last run for a couple of weeks and
Yeah.
you know, just be inside. Good afternoon. How are you doing? Kevin, I see you still enjoying the weather. And
Yeah, it's still really nice here.
yeah, you're in Tampa.
No, Longboat. Longboat Key.
Right, Longboat Key, right, just south of
Yeah.
me. And but see, Peter is showing off his New Jersey weather. No, yeah, Jersey. I don't know if can y'all see y'all can see each other, right?
Yeah.
So Peter, he just left, but Peter is outside, and and he doesn't have a shirt on, but he's just showing the top part. And I'm like, oh, enjoying the weather. He says the first nice day. So New Jersey has a nice day.
Yeah, I think some of the northern states, like I'm from Maryland, and like it's been pretty nice the past few days there.
Oh, good. Good. So see, there's Peter showing off his New Jersey weather. You see Kevin throwing you down what South Tampa looks like, I mean, what Tampa looks like, or he's just south of us in Longboat Key, but.
Oh man, I wish.
Oh, look at his view.
Oh, that's
Look,
awesome.
y'all want to tell him what you
It's
think?
nice.
Or we can all show him, right? Nice, nice, nice. So we'll give it a couple of minutes. Those of you that are here, go into, we're going to do time value of money today and go into course content information in Blackboard. And TVM problems, I think there's 2 of them that are uploaded. Upload the one that's an Excel file. And we're going to learn time value of money in using both your calculator and in Excel. So you can see the Excel sheet. It's all nice and pretty. So you're going to need your BA2 Plus calculator. And then I'm going to show you the TVM, time value of money, the TVM formulas in Excel. Business persons, so therefore business students, Excel, 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 and more Excel. Graduating with the business degree and not understanding time value of money, it's just a very common business tool and understanding that you need, and being able to calculate it in Excel, which is what most business persons do, or in your calculator if you're out and you don't have your computer with you. So everybody, BA2 Plus, and already have that open in Excel, so we'll be demonstrating it in Excel. And I'm sorry, I'm just, if I seem off, I was telling Peter, he was in the meeting earlier, that just about within the last hour, I just found out.
She just did.
There she is. Sorry, I don't know what happened. I went away. I just vanished. Ooh. Anyway, I'm back. My son and his wife that live in Los Angeles, the oldest, are both tested positive for the coronavirus, but his wife is pregnant, 35 weeks pregnant, and she is in the hospital with pneumonia, and They, of course, won't let him around, and they may have to do a C-section and take the baby. And then with both of them positive with corona, who's going to, anyway, it's just kind of a mess right now. And then, of course, as mom, I want to be in Los Angeles with my son and his wife, but I can't. So anyway, if you would keep my son, his name is John, Jon, and Maria, and in your thoughts and prayers, I'd appreciate it. Okay, so course content information. Look in the TVM problems, bring up the one that is an Excel sheet. And you can see it's a pretty sheet, and it has how you would solve the TVM problem in the BA2 Plus and in Excel. I know they talk a lot about the tables, using tables in the textbook itself. I used the tables 400 years ago when I was in school, but nobody carries around tables in their, pocket protector anymore. So calculator and BA2 Plus. Before I share and we go on to the Excel file, there's just some concepts about TVM that I want you to understand. So I'm going to bring up a Word document, a blank Word document that I'm going to share the screen with you on, and I will type the concepts that I want you to understand. So the only way, time value of money, the only way that I know how to teach it, and I'm sure there are people better at teaching it than I am, but is that $1 today is worth more than $1 tomorrow. Because the idea is I can invest $1 today and it would be worth, it can earn interest, okay? The other thing is that the dollar loses spending power because of inflation, which is something that's incorporated in whatever rate is determined. When you get into finance classes, you will learn more about how interest rates are determined and what are the components of an interest rate. Of course, one of them being a macroeconomic factor of what the Fed rate is that you hear about, and the risk level, of course, of the person themselves. I may have a different, I go and buy a car, I may have a different interest rate than somebody else because I've got really good credit, and somebody that doesn't have real good credit, so they're higher risk, are going to have a higher interest rate. So when we talk about time value of money, there are 5 inputs that we need to think about. N is the number of compounding periods. Now, what I mean by compounding is, as you read in chapter 6, is that interest can be compounded monthly, quarterly, semi-annually, or yearly. So we have to think about whether our interest, how often is the interest being compounded? For example, if I put money into a savings account and I keep it there for 2 years and interest is compounded annually, then my N would be 2. If interest is compounded monthly, then I would have 24 compounding periods in that 2 years, because they're obviously 12 months in a year, and 12 times 2 is 24. So N is the number of compounding periods. I is the interest rate per compounding period. If I have, I'm gonna do this one easy because the math is easy in the head. If it's a 12% rate, we all know that that is an annual rate. If my compounding period is monthly, then the rate would be 1%. You know, the annual rate divided by 12 because of 12 months in a year. So your interest rate, in other words, apples, you need to be matching apples to apples so that if your N is monthly, your I needs to be monthly also. Then we have payment. And payment is equal to the deposit if you're putting money into an account or the withdrawal that you have if you're taking money out of account. So for example, we're going to look at a problem where I'm trying to figure out how much money do I need to retire? How much money do I need to deposit into an account every year until the day I retire so that I can take a certain amount of money out of the account every year until I die. So that's what payment is. So payment is your deposit or withdrawal per compounding period. PV is equal to the present value, and the present value, of course, is today, present. And when we're working the problems, I want you picturing a timeline. I'm not good at drawing, but an arrow in Word, but I guess it could, but just picture a timeline. And if we're looking for how much do I need to deposit in order to accumulate this amount of money, then I'm looking for how much do I need to put into an account today in order to accumulate, say in 3 years, I need $100,000. So I want to know how much do I need to deposit today so that at the end of 3 years, it would have $100,000 in it. So the $100,000 would be the FV, which is the future value. So we're going to see, working these problems, how we use these 5 inputs to calculate the time value of money. And so, like I said, the best way that I know how to teach the whole concept is understanding that the concept all has to do with the value of money, that I can get my money to work for me and I can get a return on it. So we don't, in a business projects, when we're doing capital budgeting, you know, trying to decide, should I buy this building at this price or not? Will I get the rate of return that I want on it? All involves time value of money. Okay, we should not add money across time without thinking about the time value of money. Okay, so now that I've done this, I'm going to stop sharing and I'm going to pull up the Excel file that y'all have, and we're going to work these problems together. So can you see the Excel file okay? Is it sharing okay? All right. And sorry if I'm just dry. I'm just not very talkative, other than I am, it's a sunny day. All right. So the first question, we're going to start off pretty basic. And the first question is, what will a deposit of $9,500 at 10% compounded annually be worth if I left it in the bank for 6 years? Okay. So in our calculator, N would be what? So what is our compounding period? How often is it being compounded?
Annually.
Good, annually. And if I deposit the money today, I'm looking to see how much I would have in that account 6 years from now. So what am I looking for? What is my unknown? Because you're going to have one unknown out of the 5.
Future
Future
value.
value?
Good. So we're looking for future value. So in your calculators, you would hit 6 and then hit your N. Do you see the 5 on the 3rd row? Do you see the 5 inputs? Do you see N and then it has I/Y, PV, payment, and FV? Right. So those are the 5 inputs that we just talked about. So you hit 6 and then N. And what is my annual? What is my annual, since this is annual compounding, what is my annual rate?
10%.
10, good. Now in your calculator, you don't put 0.1, you just put 10 and then I. It knows it's a percent. So 10 and then hit I. And present value is negative 9,500. Now, why is it negative 9,500?
Because you're depositing it.
Good, I'm gonna deposit it. This has worked for me for years that I've been doing TV on problems. And I just picture it as simple as I have to take $9,500 out of my pocket to put it into the bank so that I can put money into my pocket in the future. And if I just keep that very simplistic picture in my mind, then I'm okay with my negatives and positives. So put in 9,500 and then change the sign to negative, which is the smallest on the bottom row, all the way to the right, the plus minus is the change sign. So do you see the plus/minus? So if you put 9,500 and hit that, it'll change it to a negative number and hit PV. Now payment. Am I going to be making payments into this account every year for the 6 years? No. I'm just going to put the 9,500 in today and see what it grows to. So payment is going to be 0. Get in the habit of putting in something for 4 of the 5. Of course, one is going to be one that you want, that you're going to calculate. Get in the habit, because your calculators remember what you had put in there before. And I've gotten in trouble before by not doing that. So put 0 and the payment. So now we're calculating the future value. How much would we have at the end of the 6 years? At the top left of your calculator, do you see CPT? CPT stands for compute. So then hit compute FV, which is future value, and what do you get? Somebody want to try? Okay, y'all put it in your calculator and hit compute FV.
I got 16,829.
And now in time value of money, we're not going to round. So your calculators should be set to 6 decimal places. To set them to 6 decimal places, let me see if I can remember this. Hit 6, second, and then down at the bottom, you see the period is format, and then enter. Did that work? So 6, and then the second, format, enter. Did that set your calculators to 6 decimal places? Feedback, please.
Yes.
All right. Does everybody have their calculator? Okay. All right. So yes, we get 16,829.8295. Is that?
Yep.
All right. I'm not typing the answer in there because I'm going to have it over in Excel, and I don't feel like typing it, to be honest with you. Now, in Excel, we're going to use, in Excel, N is still 6. I don't know why that's $1. I enter in 0.1. So in Excel, you need to enter in 0.1. Now you can go in and then change it to a percent, but you actually enter it in as 0.1 in Excel. In the calculator, you entered it in as 10 and then hit I. In Excel, enter in 0.1, and then I changed it to where it was a percent with 2 decimal places. Now the present value is still negative 9,500. The payment is 0. And future value is what I want to calculate. So watch what I'm going to type in the future value cell, which is going to show up here in my f of x. I'm going to hit equal, and then FV for future value, and then I'm going to open the parentheses. And you see that when I open up the parentheses, it gives me the syntax of what order I need to put the information in. So you see the first one is rate. So I'm going to click the rate, and then comma. Notice I'm not putting in the 10%. I'm putting in a cell reference, and I'll explain why in just a minute. Then it wants to know what N is. It says NPR. That means that the number of periods. So that is the 6. And then it wants me to enter in payment, comma, and then it wants me to enter in present value. And the type is 0. And I'll explain that in just a moment. And then we'll close the parentheses and hit enter. And you see that we got the same number. If I were to put that into more decimal places, we get the exact same thing that we did in the calculator. So calculating TVM in both the Excel and the calculator is pretty darn easy. Now the reason, if I look up here at my f of x, the reason that I used cell referencing instead of hard coding these amounts in was, suppose I said, well, I really need more than $16,000. Maybe I can come up with another 1,000. So what if I can put in 10,500? I just changed the PV, and you see how it automatically updated. That is the benefit of cell referencing in Excel, and you have learned this in your Excel homework that you've been doing, okay? And I said, oh, that's not, I still need more than that. So, well, maybe I can wait 6.5 years. So I'll put in 6.5 and okay, good. I'm closer. I really wanted 20,000, but I can deal with 19.5. So just with changing my inputs, then because I used cell referencing as formulas, it just will automatically update once we change the the inputs that they will automatically update for us. So this is a very basic problem where we're looking for future value. Now let's look at number 2. And number 2 says, what would a deposit of 95, same question, but here, what is the difference?
It's compounded semi-annually.
Good, it's compounded semi-annually. It's compounded semi-annually. So how many semi-annual periods in a year?
2.
2. And it's 6 years, so then what is my N gonna be?
12.
12. And my I is going to be, these are easy to do in your head, but what if the rate was 7.33 or 8.34, which are interest rates are like that. So what I would do is in my calculator, I would actually put 10 divided by 2 equal, and then hit your I. Now I know we're going to get 5. It's an, you know, a whole number, but if it was 7.33, then you would want to put 7.33 divided by 2 and then hit your I so that you don't have rounding issues. Okay. So I'm going to put in equal to 10 divided by 2. And I'm going to increase the decimal on this so that y'all can all see. And then the same thing for here, I'm going to put in 0.10 divided by 2. And I didn't put in equal. And again, I can change it to a percent. My present value is going to be what? My present value is still going to be 9,500. Payment is going to be 0. And then go ahead and calculate future value on your calculator and in Excel. Again, for the type, put 0. I promise I will be explaining that. And you should have gotten that number on both your calculator and in Excel. Please make sure you're getting it in both because, you know, on the exam, I don't know whether you're going to be using Excel or your calculator. So make sure you're efficient in both of them. You know, it might be more time doing it. You might save, it might be quicker to do it in your calculator on the exam. So how are we doing? So you see, it doesn't surprise us that we'll have more money if it's compounded semi-annually than if it's annual. Can somebody explain why? What happens with compounding? Look on page, it's in Appendix C. So look on page C-2. So what is the difference between simple interest and compounded interest? when we compound, we earn interest on interest. So compounding means that you are earning interest on your interest. So if your interest is compounded more often, in other words, the interest added to your account twice a year instead of once a year, it's going to calculate interest after 6 months. And then at the end of 12 months, you will be earning interest not only on the principal, but on the principal plus the 6 months of interest from the period before. Does that make sense? Okay, earning interest on interest. So the more often that your savings account is compounded, the more that you will have in your account at the end of a time period, as we see here. Now, banks usually compound monthly, and they add interest to your savings account monthly. So now let's take a look at number 3. How much do I have to deposit today to have $5,000 in the bank 5 years if I earn interest compounded annually? So in this problem, what are we looking for? What is our unknown?
PV.
Present
PV.
value.
Good job. So N is 5. I is 4. And here it's going to be 0.04. Present value is what I'm looking for. Now, payment. Am I going to be making any payments? Am I going to be making 5 payments of anything? Am I going to be depositing annually into the account?
No.
No. Whatever your N is, whatever you enter in as payment, it's going to think that you're making whatever, like in this case, we have N as 5. If I say I entered the 5,000 in as payment, then it would think that I'm making 5 $5,000 payments. Okay. So we're not making any payments. We're just going to put in whatever amount I need to today so that I can have $5,000 in the future. So equal, PV for present value. Open my parentheses. You see it tells you the syntax, again, of what order to put it in. So we'll put in rate, period, payment, future value, and then type, again, we'll put in 0. And that's not right. What did I do?
Is there supposed to be 1 at the end? Because you're calculating the beginning.
No. No. All right, what did I do?
You're on the calculator side of it, so the interest rate is 4, not 4%.
Ah, thank you so much. I was like, something's not right. So glad you noticed that. Thank you. So equals PV and rate. So we see the importance of the difference in entering in the interest rate on the calculator. I did that on purpose as a learning lesson. N, payment, future value. All right, that's much better. So I need to put in, this is question number 3. Yeah, 4,000. And of course we could extend the decimal points if we wanted to. and make sure that you're getting that same number in your calculator. Now, why is PV negative? Kevin, did you just raise your hand or are you pointing at birds?
No, there's a dolphin.
Oh, there's a
Sorry.
dolphin.
Yeah.
So why is PV negative? Can you show us the dolphin? Or is he?
No, it's kind of far out now.
Yeah. So can someone answer why is PV negative?
Because you're making a deposit.
Good, good, DJ, because I'm making a deposit. I got to take it. I got to take $4,109.64 out of my pocket so that 5 years from now I could put 5,000 into my pocket. All right. Now, what if the interest rate was 6%? So because I've done cell referencing, change that to 6%, and I have to put in less because I'm earning a higher interest rate. Okay? But I'm gonna put this back to 4, and that is the answer. So far, not so bad, right? So number 4. Now we're going to get into some life problems to think about. If I make equal installments, I make equal installment payments of $2,000 into my 401k with a 3% annual interest rate. You know, we're glad when we have to borrow money that it's low, but when we're trying to save money, we want a higher interest rate. But how much will I have at the end of 20 years? And if it doesn't tell you what the compounding period is, in other words, if it doesn't say compounded quarterly, compounded monthly, compounded semi-annual, then you assume annual compounding. Assume annual compounding. And we're making annual installment payments. So that's another way that I know that this is an annual compounding problem. So what am I looking for here? What is our unknown?
Future value.
Right, future value. Future value. So N is 20. And I is 3 and 0.03. What is my present value? How much do you have in the account today?
0.
0. So remember, present value, think about today. So I'm just opening up this 401k and I don't have anything in it. So my present value is 0. And my payment is a negative 2,000 because I'm going to be making $20 $2,000 payments into the account. Oh, let me get over here on the correct side. So you can put those numbers in your calculator and then do them in Excel or equal future value. And I would have $53,740.75. Y'all are as talkative as I am today, but I have a good reason. What's happening? Or are y'all just busy with the calculator and Excel? All right, I'm assuming that if you're not getting these solutions, that you'll ask me, Dr. Bostic, how did you get that? Let's do it again. Is that a good assumption? Those of you that I can't see your face, can I have a thumbs up or something? Do y'all see the reactions down? Oh, good. Thank you. Thank you, Matt and Jack and Kate. Oh, good. And Joe. Yay, Caitlin. Jordan. Yippee. All right. Thanks. All right. So now let's look at number 5. How much money do I have to deposit today to be able to withdraw $15,000 at the end of each of the next 15 years, assuming a 5% interest rate? So I want to put money, I want to know how much money do I need to put in today. So this is like a retirement question, right? I need 15,000 a year for the next 15 years. So how much do I need to deposit today? So obviously, what is our unknown? Well, what is our unknown? What are we looking for? What does the first phrase say? How much do I have to deposit today? So if it's saying today, what do you think of?
Is it payment?
Well, my payment is going to be the 15,000. So payment is 15,000 because I want to withdraw 15,000 out of an account for 15 years. So what we're looking for is present value. How much do I need to deposit into an account today so that I can afford to take $15,000 a year out for the next 15 years? Say that you're going to medical school, and and you can live on 15,000 a year, good luck, but 15,000 a year, and it's going to take you about 15 years to get through school, but I can live pretty frugally. So N is 15. And am I taking the money out? Am I taking money out annually, every month, every 6 months, every quarter? How often do I want it? Good. So our annual interest rate is 5. And so we'll have 0.05. Present value is what I'm looking for. How much do I need to have in an account today that's earning 5% interest so that I can withdraw $15,000 $15,000 every year. So I want 15 $15,000 payments. And now my future value. What would my future value be? When you finish at the end of the 15 years and you take the last $15,000 payment out, what do you want the account balance to be?
0.
0, exactly. So equal PV So if I would need to put $155,694.87 into an account today, earning 5%, so that I could afford to take $15,000 out at the end of each year. So how are we doing? Am I going too fast, too slow? And if it's too slow, let me know and we could pick the pace up. How y'all like this one? This one's gonna be fun, huh? Now, retire, dead. Are y'all still calculating? Cameron, you got them? You got it on both calculator and Excel? Cool. All right, I'm gonna move over to number 6 unless somebody goes, whoa, whoa, I need to finish 5. Now we're buying a car. And we got an interest rate of 6% for a 5-year loan with what kind of payments? Monthly. So what is our compounding period? Months, right? Months. So the purchase price of the car is $32,995 and you put down $5,000. So here we're calculating what would your monthly payment be? So you're buying a car and you want to know what your monthly payment is going to be. So N is equal to, how long is the loan?
5 years.
5 years. I need to multiply it by 12. Why?
Monthly.
Because it's monthly compounding. So there are 60 monthly periods in the 5 years. Now, what is our interest rate?
6%.
6. So I'm going to do equals 6 divided by 12 because you want the monthly interest rate. You want the monthly interest rate. So over here, I'm going to put in 0.06 divided by 12. But I have to put the equal in front of it. You know, and you can, if you convert this to a percent, you know, you could see you get the 0.5 just like you get the 0.5 here expressed as a percent. Now the present value. What is your present value? How much are you going to borrow?
Purchase price of the car minus how much you put down.
Good. The purchase price of the car minus how much I'm going to put down, which gives me, what problem is this? Number 6, which gives me what, $27,995?
Yep.
So my present is $27,995 because that's how much I need to borrow. Payment is what I'm looking for. I'm looking for what my monthly payment is. Now, what is my future value going to be? How much are you going to owe when you make your last payment?
0.
0. Now, how do we calculate payment? Equal P, oh, I'm doing it on the wrong side. You know how to calculate payment on the calculator. Equal PMT, open parentheses. Again, it's telling you the syntax. So rate, number of periods, present value, future value, and the type. Okay, you see here where I put up, let me go ahead and explain type right now. You see how I put in the 0 and it gives me 0 means end of the period and 1 means beginning of the period. So when you are in Excel, if it is an ordinary annuity, meaning at the end of each period, you put in a 0. If you were having to make the monthly payments at the beginning of the period, in other words, you go and you buy the car, and that same day you have to make your first payment. That means you're paying it at the beginning of the period. Then it would be what we call an annuity due, and it would be a 1. So the type has to do with, is it an ordinary annuity or is the annuity due? Okay. And when we make payments on a note, they're always ordinary annuities. So close my parentheses, and I see that my monthly payment would be $541.22. Is that what you got in your calculators? CPT, PMT. Okay. Let's look at number 7. They won the lottery, $150 million lottery. So $150 million lottery, I'm sorry. And you know how when you win the lottery, I've heard this, I've never won the lottery, but you know how when you win the lottery, you can take the cash all up front, or they will pay you X amount of dollars every year? Well, how do you know whether you should take all the money right now, or should you take the payout? Well, you need to do time value of money in order to figure that out. So what do you think we're looking for here?
The rate?
The rate, exactly. You're looking for the rate. Perfect. So they're going to pay my choice is that I can take $86 million today, or I can get $5 million a year over the next 30 years. So N is 30. My interest rate is what I'm looking for. My present value is how much could I get today?
Is it the 150 million?
No, if I take the cash option, what would I get today?
86 million.
Good. I would get 86,932,220 today. So that would be the present value, right? Because we're trying to figure out what rate they're using. So if they say that the present value is 86,932,20 of a 30-year, how much would they pay me every year for 30 years? 5 million, right. So what they're saying is the present value is 86 million of a 30-year, $5 million payout. Now my future value would be 0 because they're not going to pay me anymore. So now let's look and see how we would calculate the rate. So equal rate, open parentheses, and number of periods, payment, present value, future value, and then type. And what did I do incorrectly? I got, one of these has to be a negative. No, it doesn't. Let's see, H32 is in, H35. Let me do this again. Equal rate, open parentheses, in, payment, future value. Nope, I've got it in the wrong order. Payment, present value is what, H34? Yep. And then future value and type. And I still think I'm gonna get the same thing. One of these has to be negative.
Professor, there's another thing on there that says guess. What are we supposed to put there? Like after type, there's like a comma that says guess.
Yes, the guess is, I've looked it up, and it's like what you, I have no idea. Why do I want to guess at something when I can calculate it? I have yet to, I don't know. And I've looked it up, but I forgot that it says the guess. But what am I doing incorrect? Let me see if I put this in.
Put a negative for payment and it gave me 4%.
Right, and that's it. Either negative, either present value or payment has to be negative. Oh, yeah, the present value, because it would be like, you have to think about it from the lottery standpoint. And it's an either or situation where the present, so put the present value as negative or the payment as negative, and you actually get an interest rate of 3.96. So the question is that you would not, would you take the payout up front if you thought that you could, so the lottery, if you take the payout option, then they're paying you 4%. So if you think that you can do better than 4%, then you would choose the other option. Okay, so the lottery is assuming a 3.9%, 3.96 interest rate when they calculated this on this either or. So let's take, I'm going to do it in my calculator over here. Let's suppose that I put, for 30 years, I put $86,932.20 into an account, and it's going to earn 3.96% interest. And I want to know what the future value of it is going to be. So rate in payment is 0. I'll put a 0 in there. Present value. Whoa. I'd be damn rich. So if I put $86 million, so forget that, what I just did. All right. What we're trying to figure out here, let me just undo. So what we're trying to figure out here is what interest rate is the lottery assuming? So what interest rate is the lottery assuming? And they're assuming a 4% interest rate. So what would you do if they're assuming a 4% interest rate and you felt like you could earn more than 4% in another account? Would you take the money today or would you take the 30-year payout? If you thought that you could earn more than 3.9%, 3.96% rate of return, then you would take the cash payout today, because you would take that 86 million and put it into an account earning more than 3.96% interest, and you're better off. You would be able to take out more than $5 million a year for 30 years. Does that make sense? Okay, so that's how you would figure out if you win that lottery and you need help with this calculation. I'll just charge a percent of the amount. How's that? All right. So 3.96% is the amount of interest that they are assuming on that payout, on how they calculated the present value. They calculated the present value using a 3.96% interest rate. All right, now let's get to some fun stuff. All of that's fun, but this is 8 and 9 is a twofold problem. So, but read 8, you want to retire in 20 years and you need an income of $25,000 per year for 25 years. Now you're going to need a whole lot more than that to retire, but so you need income of $25,000 a year for 25 years, 9%. How much do you need to have when you retire? Okay, so let's first figure that one out. I'm going to retire in 20 years, and 9%, so 0.09. And how much money do I have in my account now?
0.
Right, I don't have anything. So assume I plan to die broke and I'm starting with 0 in the bank now. So I have 0 in the bank now. I don't know why that's showing up red. I didn't have it red. Okay, I want to retire in 20 years. I will need an income of $25,000 per year. So I want to take out present value is what we're looking for. I'm sorry. Okay, so let's read this problem. I want to retire in 20 years. I need $25,000 per year for 20. I've read this problem incorrectly, so let's just stop. I want to retire in 20 years, and I want to have income of $25,000 per year for 25 years. Assuming that I get 9%, how much money do I need to have when I retire? Okay, so what we're trying to figure out now is how much do I need 20 years from now? So how much do I need 20 years from now? How much do I need to have in my retirement account in order to be able to take out $25,000, so it's negative because I want to withdraw it. So how much do I need to take out of my account? For 25 years, I want to take $25,000 out, and I'm going to die broke. In other words, I'm not going to leave my children anything. So I'm going to have zero future value. So how much needs to be in my retirement account so that I can do this? So that I can take out $25,000 a year for 25 years. I plan on dying after 25 years. You see this part right here? So how much do I need in my account? So equal PV rate in payment, future value, 0. Oh, I was gonna say, because 25. Yeah, that's the right amount. All right. So I need to have $245,564.49 in my retirement account so that I can retire and take 25,000 out for 25 years. Okay? So now, question number 9 says, using your answer in 8, how much do you need to contribute during these 20 years in order to accumulate 245,000? So does everybody understand the problem? I know that at this point right here, you see where in between where the yellow ends and the orange starts, I need to have $245,000 and $245,564.49 right here, so that during these 25 years that I'm retiring, that I can take 25,000 out for each year during the 25 years. So I need 245,000 in my retirement account. Now I want to know, it's today. And I'm going to retire in 20 years. So how much do I need in my account? How much do I need to contribute to my 401k each year to reach my target? And my target is that 245. You see how I'm cell referencing there? Because I'm going to show you in just a minute. So I know that my future value is 245. I determined from step number 1 how much I need when I retire. So now I want to know, in order to reach my retirement goal, I'm going to retire in 20 years. How much do I need to save each year? If I have nothing in my account today, how much do I need to deposit each year into my account? So we're looking for equal payment, open parentheses, rate in PV, future value, and then ordinary annuity. So I would need to deposit $4,799.92 each year. Okay? So this is a 2-part. In order to answer the question of, I'm going to retire in 20 years, and I want to be able to take out 25,000 a year for 25 years, how much do I need to deposit into my 401k during the 20 years that I'm working? And the answer is $4,799.92. Now, I don't know about y'all, but I couldn't live on 25,000 a year. So how much, so let's see some numbers. What do you think you would need? Throw out some numbers and we'll settle on one. How much do you think you'll need each year in order to, how much would you need each year during your retirement years?
At least a decent, like 70.
Right, 75,000?
Yeah.
All right, I agree. So let's say that I need 75,000. So if I want to take out 75,000 for 25 years, then how much would I have to have in my retirement account? 736,000. How much would I have to put into that retirement account? You see why I did cell referencing here? How much would I have to save every year, put into my 401k each year in order to achieve that goal?
14,400.
Right, 14,400 a year. All right. What if you need 120,000? Oh, I don't know why I keep putting it on the wrong one. So what if I need 120,000 a year? Then I'm going to need close to 1.2 million in my account, and I would have to save 23,000 a year. Okay. Now, what if you have an OS moment and you get married, you got a job, you get married, you have kids, you're saving for kids' education, you're trying to put money into a, emergency fund account for when you're laid off because of COVID-19. Life happens. And then all of a sudden you wake up and you're 50 years old and you want to retire at 60. How much would you have to save each year? Because then I would only have 10 years to save. Look how much it goes up. So if I just wait to start saving, if I wait 10 years, it goes from saving 23,000 a year to saving 77,000 a year. Now, to save 77,000 a year, you got to be making some money and still live, right? So what is the moral of this exercise?
Start saving sooner.
Start saving sooner. The minute you get a job, even if you start saving $50 a month, you save $50 a month. You pay you first. Start saving as soon as you can. And then, when you start making more money, then do this problem right here and figure out how much money do I need to save in order to be able to retire. If you start saving, say you start working at 25 and you want to retire at 55. Oh my gosh, who gets to retire at 55? Not very many people, right? So if you start saving at 25 and you've got 30 years to save and retire at 55, then look how much you save each year. It's doable. Okay, so start saving for retirement ASAP. And this was originally 25,000. Okay, so did everybody understand those? That's back to what it was originally. And you see how I use cell referencing here so that how it was just to my benefit to do it. All right, now let's take a look at the last one. How long, now here we're looking for N. And how long does it take for $5,000 to grow into 6724.44 compounded quarterly? So the interest rate is 10. So this will be equal 10 divided by 4. Here would be 0.1 divided by 4. Okay. So does everybody understand why I divided by 4? Why did I divide by 4?
Because it's quarterly.
Because it's quarterly. Because it's quarterly. Now, am I going to be taking anything out of the account during those, however long it is? Am I going to be taking anything out? I'm putting 5,000 in, so I can take 6,724.44 out. So I'm not taking any, I'm not making any deposits or taking any money out of the account. I'm just putting 5,000 in and letting it grow. So my payment is 0. So now we're looking for N. And so I'm going to be equal NPR. NPR is number of period, N per period. And then our rate. Then payment, then present value, then future value, and type. So that's about 12 quarters. So how many years? So that's not 12 years, it's 12 quarters, which would be 3 years. So it would take you 12 quarters or 3 years with interest compounded quarterly in order for your 5,000 to grow to 6,724.44. So I think we've done a problem where you're calculating, where you've calculated either N, the rate, the PV, the payment, or the FV. And you've seen the formulas in Excel on how to calculate each one of those and in your calculator. Now, in order to get you ready for the bond problem, I want to take the problem where we bought the car, number 6. And we're going to figure out we're going to be making payments. So this was the problem where we bought a car and we're making monthly payments for 5 years. And we determined that we would make payments of $541.22. Now, every time I make a payment, part of that payment is principal and part of it is interest. That's called an installment loan. Just like when you buy your home, your monthly payment, part of it is principal and part of it is interest. So we're going to set up what's called an amortization schedule to determine how much of each payment is principal and how much is interest. Okay. So we're going to have, I'm going to create down here date, and I will put here the payment. How much of the payment is for principal? How much of the payment is for interest? And then what is the principal balance? Okay. So just for fun, let's just say that we borrowed the money on January 1st of 2020. So my first payment will be February 1st of 2020. Now let me show you something really cool. You see here how I put in January 1st and then February 1st? What do I want this to be? March 1st, April 1st, May, June, July, August, September, October, November, December, January, February, March, April, May, June, July, August, September, October, November, December, January, for 5 years. Now, do you want to type that all that time?
No.
So I can do copy the series and then bring it down. And when would it be due? It would be due at, would December 1st be my last payment of 25? So I need to continue bringing it down. Isn't that pretty cool? Come on, be as excited about this as I am. So if this is the first payment, one, so it would be due February of 25, I think. I think we're going to see that the 60th payment is here. Let's see. I can tell you right now. 43 minus 42. What is 103? No, it's going to be January. 102. Yeah. So through January 1st of 2025 would be my 60th payment. Did everybody see how I copied that series down? Try it. It's cool. Look, just for fun, I'll show you. What if you want it to be 2, 4, 6? You just want to count by twos. Neato Tapito. Okay, so that is the date of one of our payments. So how much did we borrow on January 1st when we bought our car? $27,995. And our interest rate, our monthly interest rate is 0.5%. So remember, interest, your first payment is February 1st. So my interest, remember interest is principal times rate times time. So it's going to be equal the principal times my rate times 1 divided by 12. Equal principal times the rate divided by 12, right? Why, what is that? No, that's not right. Oh, I think I need to do equal principal times, I need to do this rate because that's 0.5 and yeah, that's better. So principal times rate divided by 12. So the interest for 1 month the interest for 1 month is $27,995 times 0.05 yeah is why am I having 27,995 times my monthly interest rate is 0.005. Yeah, so 139.97 is my interest. You see what my formula up here? Let me do it again. Equals my principal times my monthly rate gives me my interest. Because my rate is a monthly rate, I don't need to divide by 12. So when I did the principal times the monthly rate, I got my monthly interest. So my principal, if $139.97.5 is the interest, then my principal is, my payment is the same every month. We figured out that the payment is $541.22, right? So my principal is $541.22 every single month. Well, if $139.75 is the portion of the payment that is interest, then 401.245 is the principal. So then my ending principal balance would be the principal balance minus the principal payment, so that after I make my first payment, the balance would be $27,593.755. Does everybody understand what I'm doing? So I owe $27,995. We calculated that my monthly payment would be $541.22. My monthly interest is $139.975. Well, if $139.975 is interest, then the payment amount minus the interest equals the amount that's going towards my principal. Okay. Well, because I used formulas, I can now just copy all the way down let's see, Command C, Command V. There we go. So my interest would be equal to, because I had my, all right, so here's another lesson. Dr. Bostic making crazy mistakes. Here we're going to learn another lesson. Right here in my interest, do you see how I cell referenced this and then I multiplied it by the rate that's in cell AB20? Well, I don't want AB20 to copy relatively. That is a cell that needs to stay static. I don't want it to copy relatively. So in this formula, I would need to put a $sign in front of the row because I don't want that row to change. So that makes it static. Have y'all used this in Excel yet, the $sign, to make it not copy relatively? So let me remove the $sign. Now, do you see how this formula is this cell times that cell? So if I copy, it's now going to be this cell, which is what I want, but notice that instead of it being AB20, it copied relatively to AB21. Well, AB21 is that number. So since I don't want it to copy relatively, I don't want the rows to increase on my percent, then if I put a $sign in front of the row, the 20, then it remains static. And now I can go in and Command copy and paste all the way down so that I end up with 12 cents as my ending balance. And that's just rounding. So we're going to see how this helps us with doing journal entries. Like when I borrowed the money, I would debit cash and credit note payable for the $27,995. Then when I made my first payment on February 1st, when I made my first payment, I would debit notes payable for the principal amount. I would debit interest expense for the interest amount, and then I would credit cash for the sum of the two. And you see how it does equal the $541.22, the amount of the payment. So that would be for the first payment. For the second payment, what would I debit the note for? So the payment I'm making on March 1st, what would I debit note payable for? How much of my March 1st payment is going towards principal? 403. And the amount going towards interest is the 137. And the sum of those two equals the amount of cash. So this is called an installment note, where every payment that you make, part of it is principal and part of it is interest. And with the ease of Excel, all I had to do was create formulas for the first row using cell referencing, and then remembering to put my percent as a absolute cell. I don't want it to copy relatively. Then I could copy and paste it all the way down, and we end up with owing 12 cents. So I guess we'd write a check for 12 cents, or actually this payment would be just 12 cents higher to get a zero balance. I don't hear any comments. So are you taking it in, understanding it, or working it on your own? Because you're going to have to do this for bonds. So let's make sure you understand it. I just got a text from my husband that my daughter-in-law is the medical doctor. She's got pneumonia. She's confirmed COVID-19. We knew that. And right now they're just going to keep her on antibiotics, and they're waiting on the OB to determine whether she needs a C-section or not, whether they want to take the baby. All right, so does anybody have any questions about this installment notes? I will upload this solution with the formulas. I won't convert it to a PDF. Usually I convert my Excel into a PDF so that you can do your own formulas. But this one I'll go ahead and upload as Excel so that you can understand the formulas. Were y'all able to recreate this amortization schedule?
Yep.
I want everybody to unmute, please.
Yes.
Yes.
Yep.
All right, so let's talk about this because it's been, y'all been quiet. So how were you on doing this amortization schedule for figuring out how much of your monthly payment is principal and how much is interest?
Good.
Ainsley, how are you doing?
I'm doing good.
Cameron,
Yeah.
Pierce,
Yeah.
Peter, Aiden,
Great.
you got it? Why is nobody talking to me?
I got it.
Pierce, Joe,
Yeah, I'm doing all right.
Jay.
Yes, ma'am.
All right, I want everybody with video on. Anybody that doesn't come with video on is absent for the day.
My camera is actually broken.
No, no, talking to these students.
Everything's good.
Yeah, I saw your email. Thank you. Vincenzo? And Zach, you're there? All right. So now I want to get a confirmation from each of you. How did you do on this installment amortization schedule? Because we're going to be doing it again in bonds. And I'm doing it now, so when we get to bonds, you know how to do this already.
It's all right. It's
Y'all
just
not
gonna
gonna
take
talk
some
to
practice.
me?
At the beginning, I was lost.
Vincenzo says he's good.
The more I worked on it, the more I've got it now.
All right. I'm going to say peace out. I hope y'all understood it because we're going to be using it again. And please make sure that you practice the time value of money, because on Thursday, we're starting bonds and we're going to have to calculate the present value of bonds using time value of money. And then we're going to have to learn the journal entries on bonds, and we have to create this amortization schedule. Okay, so I will upload this Excel file and study it so that on chapter 9, when we get into bonds, it will be smooth sailing. Is that a deal? Will y'all talk to me on Thursday?
Yeah.
I've heard Peter and Aiden and DJ. Did I hear anybody else talk to me? I hope y'all aren't mad at me. See y'all.
Alrighty.
Thank you.
Okay.
Thank you.
Thank you.